So when you work with functional groups, this takes everything that you've learned so far in terms of nomenclature. So it does things like counts the longest chain, identifies double bonds and single bonds and triple bonds, and identifying branches like methyl branches and ethyl branches and propyl branches. But then it adds one more, for lack of a better term, wrinkle to it. It adds other things that help it identify itself a little bit more specifically. So, for example, the very, very first functional group that you are going to be responsible for understanding is the alcohol functional group. The alcohol functional group is a generic term for any hydrocarbon that has an OH attached for it. So you might have heard of things like methanol or ethanol or propanol. Those are all different forms of alcohol and they all are different forms of alcohol because they have an OH attached to them somewhere. We identify them by their name by looking for the OL. The OL in the name, the ending or the suffix in this case, is how we identify it as an alcohol. Now, the identifying functional group is an OH. Okay? And so the structural formula is how we highlight the identifying functional group. So I might say something like RC with an OH attached to it. Now, I need to explain this very, very quickly. Anytime that I write an R from this point forward, I'm basically referring to the rest of the chain for the hydrocarbon itself. So generically speaking, any hydrocarbon that you could potentially draw, we can draw generically by adding an R to it. You don't get to do that on a test because that's not telling me that you understand the concept, but if you see an R, that's saying rest of the chain. So in this case here, the rest of this would be carbon with the hydroxide, making it an alcohol. Now I have to add 2 hydrogens here so that my carbon has 4 bonds. The example that I'm going to give you is methanol, which is going to have 1 carbon because it's a meth. The AN tells me it's all single bonds, and the OL tells me it's going to have a hydroxide attached to it. Now at this point, I'm going to go ahead and I'm going to add the remaining hydrogens so that the carbon has 4 bonds total. Any questions about that?
So that's what methanol looks like?
That is what methanol would look like if you were to go into the Magic School Bus and stand next to it. That is what methanol would look like. Now, an aldehyde is anything that comes from the halogen portion. And we've talked about, or alkyl halides rather. Alkyl halides are anything that come from the halogens on the periodic table. So it'd be a fluoro, a chloro, a bromo, or an iodo. And these can appear anywhere on the chain. So the identifying functional group for them would be an F, a Cl, a Br.
From who? Congratulations on my golf season.
And an I. Okay? Now, the structural formula, ladies and gentlemen, is going to be R with a carbon somewhere, and attached to it, I might say that it's like an X, where X could be any of the fluorine, chlorine, bromine, or iodine. So X could be fluorine, chlorine, bromine, or iodine. And then I have to go ahead and identify or add hydrogens so that the rest of the carbon has the rest of the 4 bonds that it needs to have. Now, in the case of the example, chloral methane, it's a little bit different. It's a different compound, but it is something that would have chlorine in it. It's a hydrocarbon that would have chlorine in it. Chloral methane would be a 1 carbon long chain with the chlorine attached to it somewhere, and we've already talked about that a little bit. And then it would have hydrogens added to the carbon so that the carbon has 4 bonds. And just like before, if we have more than one chlorine, you would call it a dichloral. Or you might say that it's a 1-chloral methane because you're following all of the rules from before. Okay. Now, the next one is something called an aldehyde. And an aldehyde has the al suffix or ending attached to the name. So it could be pentanal or butenal, something like that, or propyl something along those lines. Okay? But the big deal here is that the carbon, the very, very first carbon in the chain will have a double bonded oxygen to it. So we call that a carboxyl group or a carbonyl group. So what that looks like is you would have a carbon with a double bonded oxygen. Okay? Now, the generic format or the structural formula for it would be something that looks like this. Where this carbon is the number 1 carbon, and then going this way would be the 2nd carbon, the 3rd carbon, and the 4th carbon going to the left. Okay? So the number 1 carbon has to have a double bonded oxygen on it. Now the ethanol would be a carbon with another carbon. The AN tells me that they're all single bonded. The Al tells me that there is a double bonded oxygen on the first carbon. And then now I have to go back and add my hydrogens so that every carbon has 4 bonds. So that would look something like this. Okay? Any questions about what?
That's too many bonds to that carbon.
You're right. Sorry.
Sonny, you're actually smart.
Easy.
I got a B minus, bro.
Okay, now, next thing. The next group that you're going to be responsible for understanding is the carboxylic acid. And the carboxylic acid, you'll know it or identify it in its name by something that ends with oic acid. So it could be something like propanoic acid or butenoic acid. Okay? So the functional group here that you're going to be responsible for understanding is that on the carbon, there is going to be a double bonded oxygen and a hydroxide. Okay? So this is the identifying functional group that you're going to be responsible for understanding. Now, the generic format for that would include an R, the carbon, the double bonded oxygen, the hydroxide, and then you have to understand that this has to be on the number 1 carbon, 2 carbon, so on and so forth. So we still name it the same way, so it'd be carboxylic, or in this case it would be, the example would be ethanoic acid because of the single bond, and I'll draw that structure in a second, but it's still a matter of identifying the functional group being a carboxylic acid. Sebastian?
Wait, so you say it has to be on the 1 bond, or the 1, the 2?
The first carbon.
It always has to be the first? It can't
In order for it to be a carboxylic acid, it has to be on the first carbon.
And then same with the other one?
And same with the aldehyde, yes.
Oh yeah, it says right there, must be changed. I got it. Yeah.
Okay. Now, the ethanoic acid, the eth tells me it's a 2 carbon long chain. The AN tells me that it's the carbons are single bonded together. The oic acid tells me that on the first carbon, I'm going to add a double bonded oxygen and a hydroxide, and then I have to go back and add hydrogens so that every carbon has 4 bonds. So that's ethanoic acid. Another way to name that would be, you could call it 1 ethanoic acid, but we don't generally do that because it's always on the first carbon. Okay. The next thing that we are going to learn about is the ether. And the interesting thing about an ether is that it has two branches and no chain. So the identifying functional group for an ether is an oxygen. Okay? And so the generic format for that would be something like R bonded to an oxygen with R prime, where R prime is the second branch. So I have branch number 1 and branch number 2. Okay? So the example here is dimethyl ether. So the ether tells me that it is going to be an oxygen in the middle, and the dimethyl tells me it's a 2 carbon, or it's a 1 carbon long branch, but I happen to have 2 of them. Which would look something like that. Note there's no chain, so it's a dimethyl ether. You need to put the branches in alphabetical order, so if you have 2 different types of branches, it could be a methyl propyl ether, or it could be a butyl ethyl ether, or an ethyl methyl ether. So you have to be aware of what it's actually asking you to draw. Questions about that? All right, moving forward. Okay, now, in the next group that you're responsible for understanding is something that we call a ketone. A ketone usually ends with O-N-E or just simply the word ketone. I'm going to avoid talking about it as a ketone because I think that the O-N-E way to name it is a lot easier. So the identifying functional group here for your ketone is a carbon with an oxygen double bonded to it, but this is going to be in the middle of the chain. I can write today. Okay, so that carbon is going to be in the middle of the chain. So the generic form here would be R carbon, and I'm not going to put R prime here because it's still part of the original chain. And then the double bond here is going to be somewhere in the middle. So the 2-propanone tells me that it is a 3 carbon long chain. I know they're all single bonded. And the ONE tells me it's a ketone, which tells me there's a double bonded oxygen. And this 2 tells me the location of the double bonded oxygen. So it's on the second carbon. So now I need to go back and add hydrogen so that every carbon has 4 bonds. Now, quite possibly, the most difficult of the functional groups that you're going to be responsible for understanding is the ester. Okay? The most difficult and the identifying nomenclature characteristic is that it ends in OATE, so it's an O8. So in this case, the identifying functional group is the fact that we have a carbon, and that carbon is double bonded to an oxygen and single bonded to another oxygen, and then there's a branch. So this would be the rest of my chain. So there's a branch, and this would be my chain, and this has to be the number 1 carbon. The other thing that's important to understand about the ester is that the branch does not have to be shorter than the chain. So you could have like a pentyl propanoate which would be a 3 carbon long chain with a 5 carbon long branch. And the reason why you get to be able to get away with that is because the branch is attached to the oxygen, not the original carbon. So the generic format here would be exactly what I just drew. So I'm just going to do that. It's the generic format. Now, the example here is methyl ethanoate. So in the methyl ethanoate, the F tells me it's a 2 carbon long chain. The O8 tells me it's an ester. So I'm going to have my double bonded oxygen here, my single bonded oxygen there, and then I'm going to add my methyl branch, which is going to be right here. And so now I have to go back and add hydrogens, where this is my chain, this is my branch, and this is my number 1, 2 carbon. A lot of times people will mess this one up. All right. The next type of functional group is something that we refer to as a glycol. And a glycol is basically an alcohol, like the very, very first functional group from the other side of this sheet, except for the fact that it has more than one OH attached to it. And those OHs can be anywhere on the chain. So when we write out the prefix or the ending for these guys, you use the number of OHs in front of the OL. So diol would tell me that there's two OHs. Triol will tell me that there's 3 OHs. Okay? So this is just a characteristic where the identifying functional group would be more than one OH. And so the generic format for that would be something like could be on the first carbon, could be on the last carbon, could be spread out as in the example. In the example, it's eth-N-diol. So the eth tells me it's a 2 carbon long chain. The AN tells me it is all single bonded. The di tells me I have 2 hydroxides that I'm going to attach. And the 1 and the 2 tells me the location of those. So it's going to be a 1, 2 ethanediol. And now I need to go back and add my hydrogens. So hydrogen here, 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 here. And if I were to number it, it would be 1, 2. Can they be both up, both down, one up, one down? Doesn't matter. The next one that you're going to be responsible for understanding is something called amino. It's an amino group, or it ends with INE. So in this case, the amino group would be NH2. Okay? So when you've heard of things called amino acids, like in biology, there's some type of hydrocarbon that have an NH2 or multiple NH2s attached to them. So the identifying functional group here actually should be over here, which is the NH2, sorry. And then the generic form would be something like R, something like that. So in this case, we have ethylamine. So this one tells me that the ethyl tells me that it is a 2 carbon long chain. Ooh. All single branch, or all single bonded. And then because it's an ethyl and I have an amine all group here, it's going to be NH2. Could have been on the other one, doesn't really matter. So now I'm going to go back and I'm going to go ahead and add my hydrogens. So now I have my ethylamine. And then lastly, you're going to be responsible for understanding the nitro group. The nitro group ends with is an NO2 attachment. And so that would look something like this. okay? And now, an example here would be 1,3,5-trinitro-hexane, where the 3, the 5, and the 1 tells me the location of the nitros. The tri tells me I have 3 of them. So this is a hexane, so it's 1, 2, 3, 4, 5, 6 carbons long. They're all single bonded together. And on the 1 carbon, I'm going to have in NO2, and on the 3 carbon, I'm going to have in NO2, and on the 5 carbon, I'm going to have in NO2. And so now I'm going to go back and go ahead and add hydrogens so that every carbon is participating in 4 bonds. Okay, now, what we are going to do next is you are going to be asking the question very, very shortly, do I have to memorize all of these for Thursday? And the answer to that question is actually no. If you are going to be taking like organic chemistry in college, you will absolutely have to memorize these. But I am going to give you a half sheet of paper to help use for the homework, so you can go ahead and so you don't have to necessarily flip back and forth. But on the test, I'm going to be giving you a new one. So if you want to go ahead and write on the half sheet of paper that I'm about to give you, that's fine. But on the test on Thursday, you're going to get a clean one. So, questions?